This is a NIPS 2016 spotlight video for Multimodal Residual Network for Visual QA. Hi, I'm Jin-Hwa, or just Jin, at Seoul National University. Visual question answering is a task which needs visual information, while question answering using natural language. So multimodal learning is important to solve this kind of problems. Look at this example. Green answer shows human responses look at the image, while blue answers didn't. Therefore, blue answers may utilize their own background knowledge answering with diamond or round to the second question. Our approach is based on the study of deep residual learning by he and his colleagues. They suggested a simple method to effectively and efficiently stack insanely deep neural network with hundreds of layers using residual learning blocks. The schematic diagram shows the gay idea assume that identity mapping of X effectively approximate the desired mapping H of X. The linear mapping F of X is easy to optimize the residual mapping, hopefully than the original mapping. How can you apply this idea to multimodal tasks? Firstly, we need a residual mapping for multimodal inputs. We notice that automatic product of embedded vectors is a powerful method to learn multimodal representations. The next is choice of shock connections for multimodal inputs. Many empirical observations suggest to use a question vector for shock connection. However, we need to confirm this choice after exploring other options. We carefully select among alternative models. The proposed model structure is B. The full experimental research can be found in the paper. This slide shows the proposed model using 3 block layers, which is isogenomal 1 to 4 block layered models. We call it MLN. We use the skipped factors of Kiros et al. 2015, which provide the pre-trained models of word embeddings and GRUs for question feature vectors and ResNet for visual feature vectors. MRN significantly outperforms previous methods for both open-ended and multiple-choice tasks at the time of submission. However, the performance of number and other types are still dissatisfied compared to human performance, though the advances in the recent works was mainly for other type answers. This fact motivates the study on counting mechanism in future work. We propose a novel method to visualize attentive effect induced by automatic product in our model, though there is no explicit attention mechanism. There are the examples using the proposed visualization methods. Sometimes attentive effects are increasingly concentrating on the subject. We include more examples in appendix. Moreover, I want to share our recent study on visual question answering task. We analyzed joint resume mapping in MRN as a row rank linear pooling, achieving new state what on VQ dataset. Available in archive preprint and under review in iClear 2017.